Beyond software, future-proofing blockchains for AI, DePIN, and the next era of decentralized systems. Summary statement. This exposition explores the evolution of blockchain technology through the lens of cinematography, drawing parallels between the progression of video formats, such as RAW files, intermediate codecs, and final export formats, and the development of Layer 1 blockchains and smart contract platforms. It argues that, much like the cinema industry's shift from software-based solutions to hardware-accelerated systems to meet growing demands, blockchain technology must evolve beyond software optimizations to embrace hardware acceleration and parallel processing in order to support data-intensive applications like AI, DePIN, and the next generation of decentralized systems. The piece predicts that blockchain networks like Solana, with their focus on hardware-optimized infrastructure, will be the key players in future-proofing the decentralized ecosystem for the technological challenges ahead. Introduction. Blockchain technology has undergone rapid transformation since the launch of Bitcoin in 2009. What began as a revolutionary experiment in decentralized finance has evolved into a broad and complex ecosystem encompassing everything from smart contracts and decentralized finance, DeFi, to NFTs and AI integration. However, as the industry matures, it faces critical scalability issues, especially when confronted with the demands of new, data-intensive applications like AI and DePIN, decentralized physical infrastructure networks. In the same way that the cinema industry underwent a transformation in its approach to video formats, from the raw, unprocessed footage captured on film to optimized hardware-accelerated codecs, blockchain technology is following a similar path. The progression of video formats offers a useful analogy for understanding how blockchain technology will evolve. The raw file, Bitcoin, serves as the foundational layer, while the intermediate codecs, Ethereum, Solana, provide flexibility and efficiency for more complex applications, and the final export formats, altcoins, and tokenized platforms offer specialized solutions optimized for specific use cases. As blockchain technology adapts to these increasing demands, it will become increasingly reliant on hardware acceleration and parallel processing to scale effectively and meet the needs of applications requiring high throughput, low fees, and speed. Platforms like Solana, which prioritize these technological optimizations, are uniquely positioned to lead the way. 2. The cinematography analogy. To better understand the evolution of blockchain technology, it helps to draw an analogy to the film industry's approach to video formats. In video production, 3 main stages define the flow of data from capture to distribution. 1. Raw files. These are unprocessed files that capture all the data from the camera sensor, often in an uncompressed or minimally compressed form. They retain the most detail and flexibility for post-production. Example: Red RAW, Airy RAW, Blackmagic RAW. Bitcoin analogy. Bitcoin's base layer is analogous to a raw file because it captures the fundamental data and security of the network in an unaltered, immutable format. Like raw files, it's secure, but processing is needed for usability, using wallets or Layer 2 solutions for faster transactions. 2. Intermediate codecs. These are compressed, but still retain a large amount of detail. They are used for editing and post-production because they balance quality with file size and allow for flexible manipulation during editing. Example: Apple ProRes 422, ProRes 4444, Avid DNxHD, Cineform. Bitcoin analogy. This would align with the Layer 1 smart contract platforms like Ethereum or Solana, which process transactions more efficiently and allow for features like smart contracts and decentralized applications, DApps. These platforms have more flexibility and speed than Bitcoin's base layer, but they may not have the same level of security or decentralization. They are designed for different use cases, like programmability, but still maintain a solid level of reliability. 3. Final export formats. These are highly compressed files, optimized for easy distribution and viewing, like MP4, MOV, or JPEG, where file size is reduced, but significant data is often lost. Example: MP4, H.264, H.265. Bitcoin analogy. These would correspond to platforms that focus on user-facing, final product delivery with a lower priority on decentralization or security. They may prioritize speed and lower fees, but sacrifice some level of transparency and immutability for the sake of efficiency and convenience. 3. Layer 1 blockchains and the need for hardware optimization. Bitcoin and the raw file analogy. Bitcoin, often referred to as the original cryptocurrency, operates as the base layer of the blockchain ecosystem. Like raw files in video production, Bitcoin is secure, immutable, and foundational. However, its design also means that it is not well suited for high-speed transactions or complex operations without additional layers or modifications. The Bitcoin network is optimized for security and decentralization rather than transaction throughput or programmability. While it provides a rock-solid foundation for storing value, Bitcoin transactions are relatively slow and costly compared to newer blockchain solutions. Ethereum and Solana as intermediate codecs. Platforms like Ethereum and Solana are akin to intermediate codecs in video production. These blockchains allow for greater flexibility and speed compared to Bitcoin, facilitating use cases such as smart contracts, decentralized finance, and dApps. They are the middle ground between the raw, unprocessed Bitcoin layer and more specialized altcoins that prioritize speed and scalability. While these smart contract platforms are more efficient than Bitcoin in terms of transaction throughput and programmability, they still face challenges related to scalability, gas fees, and security. Solana, however, stands out due to its unique reliance on hardware acceleration and parallel processing to increase the performance and scalability of the network. Solana's hardware acceleration advantage. Solana's design optimizes for high throughput and low fees using advanced technologies like parallel processing and hardware acceleration. This gives it a distinct advantage over Ethereum and Bitcoin when it comes to handling the massive data demands of the next generation decentralized systems. By leveraging specialized hardware such as GPUs and customized ASICs, Solana is able to scale more effectively, providing a robust foundation for applications requiring real-time processing. As the rise of AI and DePIN projects creates an ever-increasing need for data throughput, Solana's hardware-optimized network is primed to meet the challenge. Data-intensive applications and their impact on blockchain. As AI and DePIN technologies continue to evolve, their reliance on blockchain infrastructure will only intensify. These data-intensive applications require high-performance networks capable of processing and storing large amounts of information efficiently. AI and the need for speed. AI applications demand massive data processing power. From machine learning algorithms to real-time data analysis, AI protocols need to be supported by blockchains that can handle the increasing throughput without compromising speed. Solana's hardware-optimized design is ideal for supporting these types of AI-powered decentralized applications, ensuring that they run efficiently and at scale. DePIN and infrastructure projects. Decentralized physical infrastructure networks, DePIN, are emerging as the next frontier of decentralized systems. Projects like Render Network, which began on Ethereum but migrated to Solana, rely on Solana's high-performance blockchain to provide the necessary infrastructure for decentralized rendering, AI computation, and data storage. These applications require low latency, high throughput, and cost-effective processing, making Solana the optimal blockchain for their needs. This content is brought to you by Bobby Giggs. Promote your brand here and reach a wide audience across platforms like YouTube, Instagram, and Facebook. Follow the links in the description to get started. The future of blockchain, parallel processing and hardware optimization. Hardware-optimized blockchains, the path to scalability. As blockchain technology matures, the need for scalability becomes increasingly urgent. In particular, AI and DePIN applications place growing demands on blockchain networks, requiring both speed and efficiency to handle large volumes of data and transactions. While software solutions can optimize certain aspects of blockchain functionality, hardware acceleration offers the next leap forward. Platforms like Solana are leading the charge in this area by integrating hardware-based optimizations to parallel process transactions, reduce latency, and lower fees. This approach fundamentally changes how blockchain infrastructure works, moving away from a purely software-driven model and instead relying on specialized hardware to scale with growing demands. This evolution in blockchain architecture mirrors the progression seen in the cinematography industry, where hardware advancements in camera systems, video codecs, and post-production workflows allowed for significant improvements in both performance and quality. By focusing on hardware optimization, Solana and other next-gen blockchains are positioning themselves to handle the demands of an increasingly data-intensive world, one where high throughput, low latency, and low-cost transactions will be essential for future decentralized applications. Network effects of hardware-accelerated blockchains. Another key advantage of hardware-accelerated blockchains is the network effects they generate. As blockchain networks like Solana become the go-to platforms for high-performance, low-fee applications, they attract a growing community of developers, users, and projects. These projects, in turn, further drive the adoption of the platform, creating a virtuous cycle that increases the network's value and utility over time. For example, the adoption of AI-driven projects like Render Network, as well as large-scale community token launches, such as those seen with Pudgy Penguins moving to Solana, is a direct result of Solana's ability to handle the unique requirements of these applications. This network effect not only helps Solana secure its position as a leading blockchain, but also sets the stage for further expansion into emerging sectors like Web3, AI, and DePIN. The key here is that, just as hardware-accelerated video codecs revolutionized cinematography, Solana's hardware-optimized blockchain infrastructure will continue to push the boundaries of what decentralized systems can achieve. As AI, DePIN, and other data-driven protocols become more mainstream, Solana's scalable infrastructure will play a crucial role in future-proofing the decentralized web. 6. The road ahead: the emergence of parallel processing protocols. Solana's success does not exist in a vacuum. Other blockchain protocols are also prioritizing hardware optimization and parallel processing in an effort to compete in the rapidly evolving market. Platforms such as Sui, Aptos, and SEI are emerging with similar goals of providing high-performance, decentralized ecosystems that can support next-gen applications. These protocols are based on the Move programming language, optimized for scalability, and designed to efficiently handle complex and data-heavy applications. While Solana is currently the frontrunner in hardware optimization and parallel processing, the emergence of these other next-gen blockchains is a sign of a growing trend in the blockchain industry. The recognition that software optimizations alone will not be enough to meet the demands of the next phase of decentralization. The bottleneck of traditional single-threaded execution in blockchain protocols must give way to parallel processing architectures, allowing blockchains to scale efficiently in an increasingly complex world. As the industry continues to evolve, we can expect Solana, Sui, Aptos, and SEI to play an integral role in driving the decentralized economy forward, enabling AI, DePIN, and other data-intensive applications to flourish on blockchain platforms. The Ethereum paradigm: a dead end for high-performance applications? While Ethereum remains the leading smart contract platform, its approach to scalability, primarily through optimistic rollups and Layer 2 solutions, poses limitations for next-gen decentralized applications. Ethereum's reliance on Layer 2s for scalability sacrifices composability, liquidity, and ecosystem cohesion. Furthermore, Layer 2 solutions introduce a degree of complexity that fractures the unified experience of working on the Ethereum blockchain. In contrast, blockchain protocols that embrace hardware optimization and parallel processing can natively scale to support more complex and data-intensive applications without the need for Layer 2 fragmentation. This is particularly relevant for AI and DePIN applications, which require seamless, high-throughput networks that can process vast amounts of data in real time. While Ethereum's Layer 2 ecosystem may still have a place in the broader blockchain landscape, its design choices, focused on scaling via off-chain rollups, are ill-suited for handling the growing needs of AI, decentralized infrastructure, and data-heavy projects. The future of decentralized applications lies in the hardware-optimized blockchains that can seamlessly handle high-speed transactions and high-volume data without sacrificing decentralization or security. 7. Conclusion: a hardware-optimized blockchain future. The analogy between video production and blockchain technology provides a unique perspective on the evolution of decentralized systems. Just as cinematographers transition from raw files to intermediate codecs and final export formats, blockchain technology must move beyond software-based solutions and embrace hardware-accelerated systems to scale efficiently for the future. By optimizing for hardware acceleration and parallel processing, Solana and other emerging blockchains are well positioned to future-proof the decentralized web. Their ability to support data-intensive applications, from AI to DePIN, while maintaining low fees and high throughput, gives them a distinct advantage over traditional blockchain platforms like Bitcoin and Ethereum, which struggle with scaling challenges. The rise of AI, DePIN, and other next-generation applications presents a unique opportunity for blockchain technology to evolve, and those platforms that prioritize hardware optimization will be the ones that define the next era of decentralization. As the industry moves forward, we can expect the continued adoption of Solana and other parallel processing blockchains to unlock new possibilities for decentralized systems, cementing their role as the backbone of the next generation of AI-powered decentralized applications. 8. Final thoughts. Blockchain technology has come a long way since the inception of Bitcoin. However, to remain relevant in a world increasingly driven by AI and data-intensive applications, blockchain must evolve once again. The future lies in hardware-accelerated blockchains that can scale efficiently, reduce fees, and handle the growing demands of decentralized applications. By embracing these optimizations, blockchain will not only stay relevant, but thrive in the next era of decentralization. As we look ahead, the Solana blockchain and other parallel processing protocols are poised to lead the charge, offering the infrastructure necessary to power the next generation of AI, DePIN, and beyond.